This video is designed to help you with the steps involved in solving a more complicated formula. This right here is the game plan for how to solve formulas, and basically you follow all the steps that you would do to solve an equation, with the key being after you have gotten all your variable terms on one side and moved everything else to the other side, step number 4 is complicated and has to be sort of understood on a formula basis, because it's fairly transparent when solving a basic equation and just collecting n's with like 5n plus 4n is 9n. This is one that if you go back and look at some of the harder at my previous videos, you'll see how to collect like terms when variables are involved as the coefficients. Once you've done that, you'll be dividing by, instead of just a numerical coefficient, you'll be dividing both sides by a collection of variables or an expression, which I'm just calling kind of a lump here on step number 5. And then it's useful to note restrictions that would cause a denominator to be 0, because of course you can't divide by 0. So in the next few slides we'll try a few harder variables, expressions. Okay? So here's a fairly medium style equation, and we could solve this equation, or this formula, excuse me, for any of the variables a, b, n, or d. Let's solve it for n, and let's go through the process here. So what you should do is, since there are some n's trapped in here, you're going to want to distribute so that the n terms are no longer trapped inside of parentheses, and then you can move them around freely with your equation solving techniques. Now, at this point we've simplified each side as much as we can, and our goal is going to be to move the terms around so that we have all our n terms on one side and everything else on the other. So I'm going to subtract 3bn from both sides. And that's going to give us 3a equals an minus d minus 3bn. Now, I want to isolate the variable, the terms with the variable in them, and that's this term and this term. So in order to isolate them, I need to add d to both sides. So if I add d to both sides, I now have gotten all my terms with n in it on one side and all the terms without n's in them on the other side. And the reason being, you want to solve for n in terms of other things, not including n in itself. That turns into a mess. It's called a recursive formula and can get quite tricky to figure out what to do with and lead to lots of problems. So remember, you want to get all your n terms on one side, get everything else on the other. Now, the key step here is to collect your n terms, which is to say that you have a minus 3b n terms. Now, if you go to the video on collecting like terms, you'll see why this works. But just for now, think if you distributed that n back out, you would get exactly what you have above it, what you started with. So what I've done is I've collected my n's, and this allows me now to divide by this lump, as I call it, whatever n's coefficient is. That's what I'm going to divide by. So I'm just going to write a lazy symbol of divide by the parentheses, and that's going to give me the result of 3a plus d over a minus 3b. Now, that's what n is equal to. Of course, here's the last thing. You need to consider the restriction that a minus 3b cannot be equal to 0. If a minus 3b winds up being equal to 0 for whatever you put in, okay, then you're in trouble. So you could simply write the restriction as a minus 3b. Slightly better would be to say, let's solve what has to happen if a were to equal 3b. In other words, That would not allow you, that would mean that if you subtracted 3b from a, you got 0. And what you can then say is a is not allowed to equal 3b, or b is not allowed to be 1/3 of a. I hope that's useful. Let's take a look at a couple more, another formula and maybe a couple variations. And as I've pointed out, we could have solved this one for b or d or a. And that would have meant taking probably this simplified version again, where we've simplified each side, and then looking at it and saying, let's get all our a terms together, or all our d terms together, or all our b terms together. Okay, we'll take a look on some other ones. Here's a relatively complicated formula that I'd like to solve for b, and once again we need to do a step that's going to clean things up and simplify each side. I'm going to multiply both sides by n. Now, the result of doing that, you have to make sure to distribute n to each term. So when I distribute n to the first term on the leftmost thing, the na minus b over n, the n on that I'm multiplying by and the n on the denominator will cancel, because I have na minus b divided by n and then multiplied by n. So that's going to give us na minus b. In other words, we've used that to clear the denominator, but of course we have to remember to distribute both to this term and to this term, and that of course then is going to give us minus NAC, and on the right hand side we're going to have BN. Now this problem is simplified as much as we can, and now what we need to do is look at it and say, how do we get all our B terms together and everything else on the other side? Now that should be fairly obvious at this point. We're going to add B to both sides. And once we've added b to both sides, we're going to get Na minus NaC equals b plus Bn. So what we need to do now is collect our b's, and if we do that, we're going to get b equals 1 plus n. Now, once again, think about distributing that back out. You'd get b times 1, which is b, plus b times n, which is Bn. So we've properly collected our b's using the reverse distributive property. Of course, we're using distributive property, just doing it in the reverse direction that we're used to. So we're collecting our like terms there. Now we're going to divide by that lump, divide by the lump again, and that's going to give us our nice simple answer of Na minus NaC all over 1 plus n. And that would be what b is equal to. Of course, we do want our restriction, and our restriction in this case is that n is not allowed to be -1, because if n was -1, in any substituting that we were doing, you would get a denominator of 0. Now, of course, this one is a little bit unique in the sense that each of the terms in here, actually we should just leave it like this. I was going to get a little carried away and split this into separate terms, but this is in fact the answer for this problem. And finally, we have the very same formula, but this time we'd like to solve it for n. Now, of course, these are nonsense formulas. They don't really stand for anything. But once again, we're going to distribute by multiplying both sides by n. We're going to clear denominators, excuse me. So we're going to multiply both sides by n. The result of doing that, once again, is going to be Na minus B minus NaC, do not forget that, equals Bn. And now if we wanted to collect our n's, what we're going to want to do is get all our n's on one side. So I'm going to suggest adding b to both sides, and at the same time I'm going to subtract bn from both sides. And the result of that, if you're careful, is going to be Na minus Bn minus NaC equals b. In other words, I've added b to both sides to get rid of this guy, and I've added I've subtracted bn from both sides to move this guy to the other side. Okay? So the net result of that now is that we can collect our n's. We're going to have n times a minus b minus ac, and that's going to equal b. And we can divide by our lump, the famous divide by lump process, and that's going to get us a very straightforward answer of n equals b over that lump, which is a minus b minus ac. In this case, as far as restrictions are going, it's probably just as easy to say a minus b minus ac is not allowed to be 0. I hope this has been helpful.